The story of the Manhattan Project is one of science, war, and the dawning of a new era in human history. It's a tale that combines brilliant minds, monumental ambition, and the relentless urgency of a world at war. But it's also a story of moral dilemmas, devastating consequences, and the complex interplay of science and politics. In the early 20th century, the world of physics was undergoing a revolution. Scientists like Albert Einstein, Niels Bohr, and Enrico Fermi were unraveling the mysteries of the atom, a realm so small yet so powerful that its potential energy seemed almost limitless. When Einstein's equation E equals mc squared revealed the relationship between mass and energy, it hinted at the incredible power locked within the atom. However, it wasn't until the 1930s that these scientific discoveries began to collide with global geopolitics. The rise of Nazi Germany under Adolf Hitler sent shockwaves across Europe. In 1938, German scientists Otto Hahn and Fritz Strassmann successfully split an atom of uranium in a process called nuclear fission. This breakthrough demonstrated that immense energy could be released by splitting atomic nuclei. Word of this discovery soon spread, and fears arose that Germany might weaponize this new science to create a devastating bomb. Alarmed by the potential threat, a group of physicists, including the Hungarian-born Leo Szilard, turned to Albert Einstein to warn the United States government. In 1939, Einstein and Szilard penned a now famous letter to President Franklin D. Roosevelt, urging him to consider the possibility of developing an atomic bomb before Germany could. The letter was a catalyst, leading Roosevelt to form the Advisory Committee on Uranium, which marked the early steps toward what would become the Manhattan Project. By late 1941, the United States had entered World War II following the attack on Pearl Harbor. The urgency to outpace Germany in developing an atomic bomb escalated. In 1942, the Manhattan Project was officially launched under the direction of General Leslie Groves, a no-nonsense military engineer known for his organizational prowess. Groves selected physicist J. Robert Oppenheimer as the project's scientific leader. Oppenheimer, a theoretical physicist from the University of California, Berkeley, was an intellectual powerhouse who could unify a diverse team of scientists. The Manhattan Project was named for the Manhattan Engineer District of the U.S. Army Corps of Engineers. Though much of its research and development took place far from New York City, the project involved more than 130,000 people and cost nearly $2 billion at the time, equivalent to over $25 billion today. Its operations were spread across various sites, including Oak Ridge, Tennessee, Hanford, Washington, and the secretive Los Alamos Laboratory in New Mexico. Oak Ridge became the hub for uranium enrichment. The site used massive amounts of energy to separate uranium-235, the isotope needed for fission, from the more abundant uranium-238. This process required cutting-edge technology and enormous resources. Meanwhile, in Hanford, the focus was on producing plutonium, another material capable of sustaining a nuclear chain reaction. Plutonium production involved building reactors to transform uranium-238 into plutonium-239, an entirely new element. At Los Alamos, Oppenheimer and his team of scientists worked tirelessly to design and construct the actual bomb. The laboratory attracted some of the brightest minds of the era, including Enrico Fermi, Richard Feynman, and Edward Teller. The atmosphere at Los Alamos was a mix of intense pressure and groundbreaking creativity. Scientists debated ideas, solved complex problems, and pushed the boundaries of human knowledge, all under a veil of absolute secrecy. One of the critical challenges was determining how to trigger a nuclear explosion. The team developed two designs: a gun-type bomb, which involved shooting one piece of uranium-235 into another to achieve critical mass, and an implosion-type bomb, which used conventional explosives to compress plutonium into a supercritical state. Each approach had its own technical hurdles, but both were pursued simultaneously to ensure success. As the project progressed, it became clear that Germany was not as far along in its atomic research as initially feared. However, Japan's steadfast resistance in the Pacific theater and the desire to demonstrate American military dominance kept the momentum of the Manhattan Project alive. In July 1945, the work culminated in a pivotal moment: the Trinity test. On a remote stretch of desert near Alamogordo, New Mexico, scientists assembled the world's first nuclear device, nicknamed Gadget. Early on the morning of July 16th, the device was detonated, producing a blinding flash of light, a thunderous roar, and a mushroom cloud that stretched miles into the sky. The energy released was equivalent to about 20,000 tons of TNT. Observing the explosion, Oppenheimer famously recalled a line from the Hindu scripture, the Bhagavad Gita: "Now I am become death, the destroyer of worlds." The success of the Trinity test confirmed that the atomic bomb was no longer theoretical, it was a reality. Just weeks later, this new weapon would be used in combat. On August 6, 1945, a B-29 bomber named Enola Gay dropped Little Boy, a uranium-based bomb, on the Japanese city of Hiroshima. The explosion leveled much of the city and caused immense destruction. An estimated 70,000 to 80,000 people were killed instantly, and tens of thousands more succumbed to injuries and radiation sickness in the following weeks. 3 days later, on August 9th, a plutonium-based bomb called Fat Man was dropped on Nagasaki. Though the city's hilly terrain mitigated some of the bomb's impact, it still resulted in the deaths of around 40,000 people immediately, with similar long-term casualties. These bombings devastated Japan and played a significant role in the country's decision to surrender on August 15, 1945, effectively ending World War II. The Manhattan Project had succeeded in its goal, but its legacy was far more complex. On one hand, the project showcased humanity's ability to harness the power of science for unprecedented innovation. It was a testament to what could be achieved when resources, intellect, and determination converged. On the other hand, it introduced a terrifying new weapon with the potential to annihilate entire cities and ushered in the nuclear age, a period defined by the ever-present threat of global destruction. The scientists involved in the Manhattan Project grappled with the moral implications of their work. Oppenheimer, once hailed as the father of the atomic bomb, later expressed deep regret. In a meeting with President Harry Truman, he admitted feeling as though he had blood on his hands. Many others shared his sentiments, questioning whether their scientific achievements had been worth the human cost. The Manhattan Project also reshaped geopolitics. Following the war, the United States' possession of nuclear weapons positioned it as a global superpower. However, the Soviet Union quickly began its own nuclear program, triggering an arms race that would define the Cold War. By the 1950s, both nations possessed hydrogen bombs, thousands of times more powerful than the atomic bombs dropped on Japan. Today, the legacy of the Manhattan Project continues to provoke debate. The project laid the groundwork for advancements in nuclear energy, medicine, and technology. Yet, it also raised ethical questions about the responsibilities of scientists and the limits of human ingenuity. The atomic bomb remains one of the most potent symbols of both human progress and its potential for self-destruction. As we look back on the Manhattan Project, we are reminded of the profound impact that science and innovation can have on the world. The choices made during that time shape the course of history and serve as a sobering reminder of the power and responsibility that come with knowledge. The dawn of the atomic age forever altered the way humanity views war, peace, and the fragility of life on Earth.